The following is for 2008 Math 125 Department Final. In this video, I will do number 34 and number 35. Number 34, graph the equation x plus 1 squared plus y plus 4 squared equals to 16. We can rewrite it as x plus 1 quantity squared plus y plus 4 quantity squared equals to 4 squared, which implies, and we can see right away, that the center is negative 1 comma negative 4 and the radius is 4, right? Now I think that's enough. Let's see which one give us center negative 1 comma negative 4. Clearly, well, we know that this is a circle, right? So the answer will not be C because it's not a full circle. D and E will be eliminated because the center is not negative 1 comma negative 4. You can see from D and E, both circles have radius, has center origin. Okay, so it will not be C, not be E, not E, not D and E. Okay, now the only options we have are A and B, but let's see. The center of this A here is approximately, if I try to draw it, try to get that, it seems like this is 4, so this is negative 2, this is negative 1, but the height is 3, so the center is negative 1 comma 3. Now that's not what we want. Okay, that's not what we want. Seems like B is the answer, but let's confirm. You can see that it touched there. That's the negative 1, right? Negative 2 divided by 2, that's negative 1. And apparently it confirms what we want, that the y is negative 4. So the center here is negative 1 comma negative 4. Now the radius is 4 though. The one here you can see from this point to that point, negative 1 go to the right, give me 3 here, so the radius is 4 also. But here the radius is, let's see, this is negative 4 and it touched the x-axis, so this must be 4 here, right? Okay, this must be 4. This one, so A and B both have the same radius 4, but the center are different, and part B is the one we want. Okay, so that will be, the answer here will be B. Okay, now you have to memorize this equation though. This is the equation of a circle. Number 35. Solve the system by method of substitution. Notice that this is a system, not a linear system of nonlinear equations. Okay, now seems like it is easier for us to deal with the second equation. Let's call this the first one and the second equation. The first equation, I can actually rewrite it as 5x being squared plus 3y being squared equals to 225. Now you may wonder why I want to do that. Because the second equation, you see that you have 5x, you have 3y, right? So you can solve for either one of them, and you don't need to solve for x or y. You can solve for, let's say, for 5x, right? Let's say I say 5x therefore equals to 15 minus 3y. Let's say that's the case. Now, this is the equation that I will plug into the first equation. Okay, the first equation looks like 5x being squared plus 3y being squared equals to 225. This will be 15 minus 3y, so I replace that 5x by 15 minus 3y quantity squared plus 3y quantity squared equals to 225. Now I will FOIL this part. There will be 225 minus 90y plus 9y squared plus 9y squared equals to 225. Okay, again, that's if I FOIL these, I will get these. Okay, I hope you can see the shadow. And then I can subtract by 225 both sides and combine like terms. Now I have 18y squared minus 90y equals to 225 minus 225, that's 0. Okay, so notice that I combine 9y squared with 9y squared, I get 18y squared, negative 90y, and then 225, if you move it to the other side, that cancels, right? Okay, or you can also say 225 here, you move it to the left hand side, because we know that will be a quadratic equation, right? Now from here, then I will factorize the 18y, because that's the common factor. Then I have y minus 5 here equals to 0. Now from here we see that y equals to 0 or y equals to 5. Okay, this is my y1, this is my y2. Now from here, then I plug it into this equation here, easier, right? I will plug it into the second equation. For y1 equals to 0, what will that be? 5x equals to 15 minus 3 times 0. Then 5x equals to 15, so x equals to 3, which implies the coordinate is 3, 0. But that's only one of them though. That's only for y1 equals to 0. Now how about when y2 equals to 5? When I plug it in again, 5x minus equals to 15 times 3 times 5, right? You see 5x equals to 15 minus 15, that's 0, so x equals to 0, which implies the coordinate we have is 0, 5. So we have these two solutions. The answer will then be A. Okay, this is again from Fall 2008 Math 125 Department Final, number 34 and number 35.